This is a 555 light theremin. The main components of this circuit include the power source, which would be connected to the positive and negative buses, here and here, the speaker, which in this case is an 8-volt speaker, the 100 microfarad capacitor, the 555 IC chip, 2 resistors, which are 10 kilo ohm resistor and a 1 mega ohm resistor, 2 0.22 microfarad capacitors, and the LDR itself, which we will go into detail on later. So how this circuit functions is that whenever the power is connected here, the 100 microfarad capacitor starts to charge. As it charges, it's kept track of by the threshold pin, which is part of the 555 IC chip. Once the charge of the capacitor reaches 2/3 the voltage of the power source, pin 6 detects this and switches off or puts on the low value for pins 7 and pin 3. Since the capacitor is attached to pin 3, that means that it's no longer having a source of power, and so it begins to discharge. When the capacitor is discharging, as soon as it reaches a voltage equivalent to 1/3 that of the power source, the trigger pin, pin 2, right here, detects it. Pin 2 then sends a high voltage to pin 3, which results in the capacitor to start charging again since it now has a source of power. This makes it cycle through because now that it's charging again, it's just as it was when the power source was first connected. So this creates the charge-discharge cycle of the actual circuit. The reason why this is important is because as the capacitor charges and discharges, it causes the output of pin 3 to go high and low, which is the square wave function, and that is then put to the speaker, and that comes out as sound. The place where the LDR comes in is that as you expose it to more and less light, the resistance changes, which changes the frequency of the discharge-charge cycle of the actual circuit. And what this does is it changes the frequency and pitch of the actual tone the speaker emits itself. And we can see this here.